November 3rd, 1177. The scorching sun beat down on the plains near Montgazard, about 30 miles from Jerusalem. Baldwin IV, the teenage leper king of Jerusalem, watched from his saddle as Saladin's massive army approached. 26,000 Mamluk and Ayyubid warriors, the finest cavalry in the known world, their armour glinting like a river of steel across the desert. Baldwin had 500 knights and maybe 2,000 infantry. Any rational commander would have retreated, but among those infantry were crossbowmen, men carrying weapons that would help turn the tide of what should have been a massacre into one of the most stunning victories of the Crusader era. The crossbow wasn't just a weapon. It was a revolution wrapped in wood and steel, a device so effective at killing armoured men that the Catholic Church tried to ban it. A peasant with 3 weeks of training could kill a knight who had trained since childhood. This wasn't just controversial. It was heresy against the entire social order of medieval warfare. But in the brutal mathematics of Crusader warfare, where European armies fought thousands of miles from home against enemies who outnumbered them, the crossbow became not just useful, but absolutely essential for survival. The story of the crossbow begins long before the Crusades, but it's in the furnace of those holy wars that it truly came into its own. The basic principle was ancient. The Greeks had used an early version called the gastrophetes, the belly bow, as far back as the 5th century BC. The Chinese had been using crossbows for over 1,000 years, but the European crossbow of the 11th and 12th centuries was something different, refined, deadly, and about to change warfare forever. The genius of the crossbow was mechanical advantage. A man could use his entire body weight and leverage to span or draw a crossbow that delivered force far exceeding what he could achieve with a regular bow. The bow of a crossbow was typically made from wood, horn, and sinew laminated together, or later, from steel. When drawn and locked into place with a simple trigger mechanism, it held enormous potential energy. Release that trigger and a bolt, the proper term for a crossbow projectile, not arrow, flew with devastating force. The power was shocking. A good war crossbow from the 12th century could penetrate chainmail at 50 yards. At close range, nothing worn by a soldier in 1100 could reliably stop it. Knights spent their entire lives training for combat. Their armour cost as much as a village, their war horses were worth fortunes, and a crossbowman who'd been training for a month could kill them with a single shot. This was the weapon that arrived in the Holy Land with the First Crusade, and it terrified everyone who faced it. But here's what made the crossbow truly revolutionary in the context of the Crusades. It wasn't just about power, it was about who could use it. Training a longbowman, the English would later prove, took years. You needed to build the specific muscles from childhood, develop the technique, master the art of instinctive shooting. A longbowman was a specialist, expensive to train, difficult to replace. A crossbowman needed strength, sure, but the weapon did most of the work. The mechanical advantage of the spanning mechanism meant that average men could wield devastating power. You could take a merchant, a farmer, a craftsman, give them a few weeks of training, and they could kill at range. For Crusader armies constantly struggling with manpower shortages thousands of miles from Europe, this was transformative. The Crusaders arriving in the Holy Land in 1096 brought with them crossbows that were already formidable but would evolve rapidly under the pressure of constant warfare. The earliest types used in the First Crusade were relatively simple. A wooden stock, a bow made of composite materials, and a simple stirrup at the front where the crossbowman could place his foot to brace the weapon, while pulling back the string with both hands. This hand-spanning method was the weakest but fastest. It limited the draw weight to what a man could pull with his arms and back, typically around 150 pounds of force. Still enough to be lethal, but there was room for improvement, and improve they did. By the time of the Second Crusade in 1147, crossbow technology had advanced significantly. Craftsmen had developed the belt hook or waist spanning method. The crossbowman wore a hook on his belt. He'd place his foot in the stirrup, hook the string with his belt hook, and stand up using his legs, the strongest muscles in his body, to draw the string. This allowed for draw weights of 300 to 400 pounds, nearly doubling the power. A bolt from one of these weapons could punch through a knight's helmet at 60 yards. But the Muslims weren't sitting idle. The Mamluks, in particular, were master horsemen and archers. They could shoot composite bows from horseback with devastating accuracy, a skill European knights couldn't match. The Crusaders needed something that could compete with this mobility and rate of fire while maintaining the crossbow's penetrating power. Enter the goat's foot lever, one of the most ingenious mechanical devices of medieval warfare. This was a lever system that used compound mechanical advantage. The crossbowman would hook the lever to the string, place his foot in the stirrup, and work the lever back and forth. Each pump of the lever drew the string back incrementally. It was slower than hand spanning, taking perhaps 15 to 20 seconds to reload, but it allowed draw weights of up to 600 pounds. At these forces, crossbow bolts became armour-defeating weapons that could penetrate almost anything at close range. The Italian city-states, particularly Genoa, became famous for producing the best crossbowmen in Europe. Genoese crossbowmen were professionals, mercenaries who hired out to the highest bidder. Many served in the Crusader kingdoms, bringing with them not just skill, but also the latest innovations in crossbow design. By the late 12th century they were using windlass crossbows, the most powerful personal missile weapons of the medieval period. The windlass was a cranking mechanism, 2 or 3 hooks attached to the string connected by rope or chain to a small winch built into the crossbow stock. The crossbowman would place his foot in the stirrup and turn the crank, slowly drawing back the string against draw weights that could exceed 1,000 pounds. These weapons were monsters. A windlass crossbow could shoot completely through a man in chainmail at 100 yards. The bolt would enter through the front, exit through the back, and keep going. Knights hit by these bolts didn't just die, they were nailed to their horses or pinned to the ground. The bolts themselves were works of deadly craftsmanship. Unlike arrows, which were long and light, crossbow bolts were short and heavy. Typically 12 to 16 inches long, they were essentially flying spikes. The heads came in various designs, each optimized for different targets. Bodkin points were narrow, needle-like tips designed to punch through mail. The entire purpose was penetration. Against the quilted armour and mail that most soldiers wore, bodkin points were horrifyingly effective. They'd slip between the links of mail or simply punch through the rings, and the heavy bolt would carry the point deep into the body. Broadheads were wider, designed to cut rather than pierce. Against unarmoured targets or horses, these caused massive bleeding wounds. A horse hit by a broadhead bolt in the neck or chest would bleed out in minutes. And in Crusader warfare, killing the enemy's horses was often as important as killing the men. A dismounted Mamluk cavalryman lost most of his tactical advantage. There were also specialised bolts. Fire bolts, wrapped with cloth soaked in pitch or oil, could be lit and shot to set fire to siege equipment or buildings. Barbed bolts had backwards-facing hooks that made them agonising to remove, often doing more damage coming out than going in. Some bolts were even poisoned, though this was considered dishonourable and was relatively rare. The real genius was in the fletching. Crossbow bolts used shorter, stiffer vanes than arrows, often made from leather or thin wood rather than feathers. This gave them stability in flight despite their short length and heavy weight. A well-made bolt would fly straight and true up to 400 yards, though effective combat range was typically under 100 yards, where accuracy and penetration were both reliable. Let's talk about what it was actually like to face crossbow fire. Imagine you're a Mamluk warrior, one of the elite slave soldiers who formed the backbone of Muslim armies. You've trained since childhood in horsemanship and archery. You're wearing a mail hauberk that cost more than a farmer would earn in 5 years. You're confident, skilled, and you're charging toward a Crusader position. You can see the crossbowmen, maybe 50 of them, standing in formation. They're not particularly impressive looking, not knights, just men with wooden weapons. Then they shoot. You don't hear a whistle like with arrows. Crossbow bolts are too heavy and fast for that. You hear a series of sharp cracks as the triggers release, then a sound like tearing cloth as the bolts cut through the air. The man next to you is hit. The bolt punches through his mail just below the ribs and comes out his back. He doesn't scream immediately. The shock is too great. He just looks down at the shaft protruding from his chest, confused, then topples from his horse. Another man takes a bolt through the thigh. It goes through the muscle and pins his leg to his saddle. He's screaming now. A horse goes down, a bolt through its neck throwing its rider, and you realise that the crossbowmen are already reloading. This was the psychological horror of facing crossbows. Unlike archers who shot in high arcs, crossbowmen shot flat trajectories, point blank. You could see them aiming at you specifically, and while they were slower to reload than archers, each shot was almost guaranteed to kill or maim if it hit. There was no wounding shot with a crossbow. You were either untouched or you were down. Muslim chroniclers wrote with a mixture of respect and horror about Frankish crossbows. Usama ibn Munkid, a Syrian nobleman and warrior who fought against the Crusaders for decades, described seeing a knight hit by a crossbow bolt that went through his mail, through his body, and buried itself in his saddle. The knight died before he could fall. Usama called crossbows the most treacherous of weapons, not because they were dishonourable, but because they made traditional martial skill almost irrelevant. A great warrior could be killed by a nobody with a crossbow. The military impact in specific battles was profound. At the Battle of Montgazard in 1177, the battle I opened with, crossbowmen were crucial to the Crusader victory. Baldwin's tiny army was outnumbered more than 10-1, but his crossbowmen were able to disrupt Saladin's cavalry charges. Mamluk cavalry relied on mobility and shock. They'd charge in, shoot their bows, wheel away, charge again. It was a tactical system perfected over centuries. But crossbowmen could target the horses, and killing a warhorse meant stranding a cavalryman. At Montgazard, Crusader crossbowmen killed enough horses in the opening phases of the battle that Saladin's numerical advantage was blunted. When Baldwin's knights finally charged, they hit an enemy formation that was already disrupted and demoralized. Saladin himself barely escaped. His army was shattered. It was one of the worst defeats of his career, and crossbows had played a crucial role. At the Siege of Acre from 1189 to 1191, crossbows were the defining weapon of the siege. The Crusaders besieging the city were themselves besieged by Saladin's relief army. For 2 years, the Crusaders held a thin perimeter, constantly under attack from both the garrison inside Acre and Saladin's forces outside. Crossbowmen were essential to their survival. They could shoot from prepared positions, using pavises, large shields that could be propped up for protection, and rain bolts on any Muslim force that tried to assault their lines. Saladin tried repeatedly to break the Crusader siege lines and couldn't. The crossbow fire was too intense. Any attack would lose a third of its men before even reaching Crusader positions. Muslim archers could shoot back, but arrows were less effective against men in cover, while crossbow bolts punched through shields and light fortifications. When Acre finally fell in 1191, it was in part because the garrison had simply run out of men to defend the walls. Crossbow fire from Crusader siege towers and positions had systematically picked off the defenders over months. Richard the Lionheart, arriving during the Third Crusade, understood the value of crossbows perfectly. His armies included hundreds of crossbowmen, both professional Genoese mercenaries and English soldiers he'd trained. At the Battle of Arsuf in 1191, Richard used crossbowmen in a way that became a model for Crusader tactics. He arranged his army in a defensive formation while marching along the coast toward Jaffa. The crossbowmen marched on the outside of the column, forming a moving wall of missile fire. Saladin's cavalry harassed them constantly, but every charge was met with crossbow volleys that emptied saddles and killed horses. Richard ordered his crossbowmen to shoot in rotation. Half would shoot while the other half reloaded, maintaining constant fire. It was exhausting work in the brutal heat, but it worked. Saladin's cavalry couldn't break through the crossbow screen. When Richard finally gave the order to charge, his knights hit an enemy already worn down by hours of attrition. The Muslim army broke and Saladin retreated. Crossbows had provided the shield that allowed Richard's hammer to strike, but crossbows weren't just for set-piece battles. In the constant skirmishing and raiding that characterized Crusader warfare, they were invaluable. Crusader castles, those massive fortifications like Crac de Chevalier that still stand today, were designed with crossbows in mind. The arrow slits, those narrow vertical openings in the walls, were specifically designed for crossbowmen. A man with a crossbow could stand safely behind several feet of stone, nearly invulnerable, and shoot through a slit barely 6 inches wide. For attackers, trying to storm a castle defended by crossbowmen was nightmare-inducing. You'd be climbing a ladder or approaching a wall, completely exposed, and crossbow bolts would start hitting you from slits you could barely see. There was no way to shoot back effectively. Archers couldn't hit targets through arrow slits. The openings were too narrow and the defenders too well protected. But the crossbowmen inside could take their time, aim carefully, and kill with nearly every shot. The Mamluks, learning to counter crossbows, developed their own versions, though they never abandoned their traditional composite bows. Arab and Turkish crossbows tended to be lighter and faster to reload than European versions, sacrificing some power for rate of fire. This made sense given their tactical doctrine. They were fighting mounted, often shooting from horseback or at least while mobile. A lighter crossbow fit their style better, but they also developed specialised troops, heavily armoured infantry who carried large shields and whose job was to soak up crossbow fire while their own archers shot back. These were the Nafatun, troops equipped with various projectile weapons including crossbows of their own, incendiary weapons, and captured European crossbows. By the late 12th century, both sides in the Crusades were using crossbows extensively, locked in an arms race of penetration versus protection. This leads us to armour development. The crossbow didn't just change tactics, it changed what men wore into battle. In the early Crusades, most soldiers wore mail, interlocking iron rings that provided decent protection against cuts and some protection against arrows. But mail was vulnerable to crossbow bolts, especially bodkin points. The pressure was on armourers to develop something better. The response was coat of plates, early plate armour. Metal plates were attached to the inside of a cloth or leather garment, protecting vital areas while maintaining flexibility. By the 13th century, this evolved into more extensive plate protection. Breastplates, backplates, arm and leg defences, all designed to deflect or stop crossbow bolts. The arms race was on. Stronger armour led to more powerful crossbows. Windlass crossbows with draw weights over 1,000 pounds appeared specifically to defeat the improved armour, and armourers responded by making armour thicker and better angled. This cycle continued for centuries, ultimately leading to the full plate armour of the 15th century, which was in many ways a response to crossbow threat. The Church's attitude toward crossbows is fascinating and reveals how threatening they were to the established order. In 1139, the Second Lateran Council, under Pope Innocent II, issued a decree. Canon 29 specifically prohibited the use of crossbows, and also bows, against Christians, calling them hateful to God and unfit for Christians. The penalty was severe. Those who used such weapons were threatened with anathema, essentially excommunication. Why would the Church ban a weapon? Because it undermined the entire feudal system. Knights were the military elite because they had the resources and time to train from childhood and could afford expensive equipment. This made them both militarily dominant and socially superior. Their position at the top of society was justified by their role as warriors. The crossbow threatened this. A peasant with a crossbow could kill a knight. This wasn't just militarily problematic, it was socially revolutionary. If any commoner could kill a noble, what did that say about divine order and social hierarchy? But here's the thing. The ban was almost completely ignored, especially in the Crusades. The papal prohibitions specifically exempted use against infidels and enemies of the faith. So Crusaders could use crossbows against Muslims no problem. In practice, everyone used crossbows against everyone. The ban was unenforceable and impractical. By the 13th century, even the Church had given up, and crossbows were standard equipment in every European army. The social revolution the Church feared came anyway, just more slowly. The crossbow and later the longbow and eventually gunpowder weapons gradually eroded the dominance of heavy cavalry and aristocratic warriors. The age of the common soldier had begun, and the crossbow was one of its founding weapons. Different cultures brought their own innovations to crossbow design. The Byzantine Empire, that last remnant of Rome clinging to Constantinople, had maintained crossbow traditions from ancient times. Byzantine crossbows, or solinarians as they sometimes called them, were often lighter than Western European versions but ingeniously designed. The Byzantines were masters of mechanical warfare, and their crossbows sometimes incorporated metal triggers and sophisticated spanning mechanisms. Byzantine manuals of war, particularly the Strategikon and later military texts, described precise tactics for crossbow use, how to form up crossbowmen with other troops, how to maintain volley fire, how to protect them from cavalry. Much of this knowledge influenced Crusader tactics when Western Europeans finally encountered Byzantine methods. The Chinese, meanwhile, had been using crossbows for over a millennium before Europeans perfected them. Chinese crossbows, or new, were different in design but similar in principle. They often used bronze triggers, some incredibly complex with multiple moving parts. Chinese military texts like the Wujingzong Yao from 1044 described crossbow tactics in detail, including volley fire by ranks and specialized crossbow formations. While there's debate about how much direct technology transfer occurred, it's worth noting that by the time of the Mongol invasions in the 13th century, crossbow technology from east and west was starting to influence each other through the Silk Road and through captured weapons and craftsmen. Mongol armies, which conquered from China to Eastern Europe, used crossbows alongside their famous composite bows, and they certainly encountered Crusader crossbows in the Middle East. The craftsmanship involved in making a quality crossbow was extraordinary. A master bowyer, the craftsman who made the bow part of the crossbow, would typically use laminated construction. A wooden core, often yew or ash, would be backed with horn and sinew. Horn compresses well, sinew stretches well, and wood provides the structure. Together, they created a composite that could store enormous energy. The horn usually came from water buffalo or cattle, cut, boiled, shaped, and glued to the wood with hide glue. Sinew, usually from deer or cattle, would be processed into long fibres and glued to the back of the bow in multiple layers. Each layer had to dry completely before the next was added. Building a composite bow could take months. Steel bows, which became more common in the 13th and 14th centuries, were even more complex. They required skilled metalworking to forge a piece of steel that was springy enough to flex, but strong enough not to break. The curve had to be precise. Too much and it would be too hard to span. Too little and it wouldn't store enough energy. Master crossbow smiths were highly valued and well paid. The stock, the wooden body of the crossbow, was usually made from hardwood like oak or walnut. It had to be strong enough to contain the enormous forces involved when the bow was drawn and released. The groove where the bolt sat, called the channel or track, had to be perfectly straight and smooth, or the bolt would wobble in flight. The trigger mechanism was the most complex part. Early crossbows used simple hooks that the string caught on, released by a lever. But by the Crusader era, triggers had become sophisticated. A rotating nut, typically made of antler, bone, or hardwood, would hold the string. Pulling the trigger would rotate the nut, releasing the string. This required precision engineering to medieval standards. The nut had to be perfectly round and balanced, or the release would be uneven, affecting accuracy. Some high-end crossbows had metal triggers with multiple parts, allowing for a smoother release and better accuracy. The spanning mechanisms were their own feats of engineering. A goat's foot lever used compound leverage through a two-piece lever that folded. The mechanical advantage was around 5-to-1, meaning 50 pounds of force applied to the lever would draw a 250-pound bow. The windlass was even more impressive. Using a cranking mechanism with a gear ratio, it could provide mechanical advantage of 10-to-1 or even higher. A man could span a 200-pound crossbow with a windlass, something physically impossible by hand. These devices had to be precisely made, or they'd bind up or break under the strain. Good spanning mechanisms were almost as expensive as the crossbow itself. Now let's talk about training and the reality of being a crossbowman in the Crusader armies. You'd typically start with a lighter crossbow, maybe 150 to 200-pound draw weight, to learn the basics. The first skill was loading. With a hand-spanned crossbow, you'd place your foot in the stirrup, hold the bow firmly against the ground, grip the string with both hands and pull up while keeping the bow down with your foot. It required technique. Pull evenly, or the string would slip to one side. Pull smoothly, or you'd strain your back. Once the string was seated in the trigger mechanism, you'd load a bolt into the channel, making sure the fletching was oriented correctly. The bolt had to sit in the channel with the notch at the back engaged with the string. Aim by looking down the length of the bolt, using the bolt itself as your sight. The crossbow stock might have simple notch sights, but mostly you aimed intuitively. Squeeze the trigger, don't jerk it or you'd throw off your aim. The crossbow would recoil back into your shoulder. With powerful crossbows, the recoil was substantial, like a rifle shot. With spanning levers or windlasses, the process was more complex, but the principle was the same. Hook the device to the string, work the mechanism, seat the string, load, aim, shoot. Professional crossbowmen could maintain a rate of fire of about 2 to 3 aim shots per minute with a windlass crossbow, maybe 5 to 6 with a lighter hand-spanned version. Compare this to a skilled longbowman who could shoot 10 to 12 arrows per minute, and you see the trade-off. The crossbow was slower, but each shot was more powerful and required less skill to be effective. In Crusader armies, crossbowmen were often organised in pairs or small teams. One man would shoot while another spanned his crossbow. They'd alternate, maintaining a higher rate of fire. This required coordination and trust. You were depending on your partner to keep shooting while you were vulnerable during the reloading process. The physical toll was significant. Spanning a heavy crossbow dozens or hundreds of times in a battle was exhausting. Your hands would cramp from gripping the lever, your legs would burn from bracing against the stirrup, your shoulders and back would ache from the repetitive motion. Professional crossbowmen developed specific muscles, overdeveloped shoulders and arms, powerful legs. They also developed injuries. Repetitive strain injuries to wrists and elbows were common. Backs gave out from years of the spanning motion. Some crossbowmen wore padded gloves to protect their hands from blisters and the string. They'd wrap their fingers to prevent injuries. In hot climates like the Holy Land, the physical exertion was even worse. Fighting in armour in 100-degree heat while working a windlass crossbow was brutally hard work. But the payoff was worth it. A trained crossbowman was valuable. Professional Genoese crossbowmen could command good wages, sometimes equal to what a man-at-arms, a mounted soldier, would make. They were specialists. Crusader lords would compete to hire good crossbowmen for their garrisons and armies. In the constantly undermanned Crusader kingdoms, where European manpower was scarce, crossbowmen were essential. They could be recruited locally, trained relatively quickly, and were effective in both siege warfare and field battles. Some crossbowmen became quite wealthy, at least by common soldier standards. They'd own their own equipment, travel between employers, and build reputations. There are records of individual crossbowmen being named in contracts and being specifically requested by nobles. The tactical flexibility of crossbows was another huge advantage. In sieges, they were invaluable for both attackers and defenders. Attacking a fortified position, crossbowmen would be in the siege lines, shooting at defenders on the walls. They'd protect the men building siege engines, target enemy leaders, and suppress defensive fire. When siege towers were finally rolled up to walls, crossbowmen would be on the upper platforms, shooting down at defenders to clear the ramparts for the assault troops. Defending a siege, crossbowmen were the primary means of killing attackers at range. They'd shoot from arrow slits, from behind battlements, from towers. Every approach to the walls would be covered by crossbow fire. At the Siege of Acre, both sides had hundreds of crossbowmen. The exchanges of fire were constant, day and night, for months. Bolts would be sticking out of wooden shields and fortifications like porcupine quills. In field battles, crossbowmen provided the ranged firepower that Crusader armies desperately needed. Most Crusader armies were heavy on cavalry and light on missile troops compared to their Muslim opponents. Mamluks and Turks were master horse archers who could harass and wear down an enemy with arrows while staying out of reach. Crossbowmen gave Crusaders a way to fight back. They couldn't shoot as fast as horse archers, but each hit was devastating, and unlike longbows, which required years to master, crossbows could be used by men who'd never shot a missile weapon before in their lives after just weeks of training. This was crucial for Crusader armies that were constantly integrating new arrivals from Europe who had no experience with Middle Eastern warfare. In raids and skirmishes, crossbowmen were force multipliers. A small group of knights with a few crossbowmen could hold off much larger forces. The crossbows provided covering fire while knights manoeuvred. They could kill enemy leaders, disable horses, and generally make attacking Crusaders much more costly. Muslim armies learned to be wary of even small Crusader forces if they included crossbowmen. There are numerous accounts of raiding parties being driven off by a handful of well-positioned crossbowmen shooting from cover. The psychological effect was significant. Soldiers knew that crossing open ground under crossbow fire meant casualties. This made them hesitant, slower to attack, more cautious. In warfare, especially in the close quarters fighting of the Crusader period, psychological advantage mattered enormously. The evolution of crossbow tactics over the Crusader period is fascinating. Early on, crossbowmen were used fairly simply, as static shooters who'd take position and shoot at targets of opportunity. But as experience grew, tactics became more sophisticated. The rotation shooting I mentioned earlier, where half the crossbowmen shoot while the other half reload, became standard. This required discipline and coordination, but doubled the effective rate of fire. Crusader commanders learned to position crossbowmen in depth, multiple ranks, so that even if the front rank was overrun, there were more shooters behind. They learned to mix crossbowmen with spearmen, the spearmen providing protection against cavalry charges, while the crossbowmen shot over their heads or from behind their shields. This combined arms approach made Crusader infantry far more effective than they'd been in early battles, where they were often just swept aside by Muslim cavalry. The use of pavises, large shields, became increasingly common. A pavise was essentially a portable wall. Made of wood, sometimes covered with hide or metal, it could be propped up on the ground with built-in supports. A crossbowman would crouch behind it while reloading, then stand or lean around it to shoot. Pavises were often painted with heraldic designs or religious symbols, and they provided protection not just from arrows, but also from crossbow bolts shot by the enemy. Groups of crossbowmen with pavises could form temporary fortifications, plant the shields in the ground, creating a wooden wall, and shoot from behind them. This was especially useful in sieges or when defending a position. At Montgazard and other battles, Crusader crossbowmen used pavises to create strongpoints that anchored the defensive line. As crossbows became more powerful, the arms race with armour intensified. By the late Crusader period, in the 13th century, the heaviest crossbows could defeat almost any armour at close range. Tests done with modern recreations have shown that a heavy war crossbow with a steel bow and a bodkin point bolt can penetrate mild steel plate at ranges under 50 yards. Medieval armour was generally better quality than mild steel, but the principle holds. At close range, nothing was proof against the heaviest crossbows. This led to another tactical development, shooting from ambush or from very close range. Crossbowmen would let enemy cavalry charge within 30 or 40 yards before shooting, maximising penetration. It required iron nerves. Watching armoured cavalry thundering toward you and holding your shot until they're almost on top of you took incredible discipline. But those close-range volleys were devastating. Horses and riders would go down in heaps, tangled together, creating obstacles that disrupted the entire charge. The crossbow also played a role in naval warfare, which was important in the Crusades. Ships carrying crusaders to the Holy Land would embark crossbowmen for defence against pirates or Muslim navies. In ship-to-ship combat, crossbows were ideal. The stable platform of a ship allowed for accurate shooting, and the penetrating power of bolts could pierce the sides of wooden vessels at close range. During the siege of Damietta in Egypt in 1218, Crusader ships equipped with crossbowmen fought naval battles on the Nile. The crossbow fire from ships was so effective that it discouraged Muslim vessels from closing to boarding range. Crossbowmen on Crusader ships could also provide covering fire for beach landings, shooting at defenders on shore while troops landed. This made amphibious operations far more viable. The economic impact of the crossbow industry was significant. Producing thousands of crossbows required specialised craftsmen, raw materials, and industrial organisation. Cities like Genoa, Pisa, and later German cities became centres of crossbow production. They'd have entire districts where bowyers, stockmakers, metalworkers, and other specialists would work. The Genoese in particular made crossbow production a major industry. They exported crossbows across Europe and to the Crusader states, and their mercenary crossbowmen were in demand everywhere. This created wealth for the Italian city-states, which helped fund their own military and political ambitions. The crossbow industry was an early example of military-industrial complex, where weapons production became a significant economic activity that influenced politics and warfare. The logistics of supplying crossbowmen in the field were complex. Each crossbowman needed not just his crossbow, but also bolts, lots of bolts. A single crossbowman might carry 20 to 40 bolts in a quiver, but in extended combat he could shoot through that in minutes. Supplying sufficient bolts to an army was a major undertaking. Bolts were produced by the thousands by specialists called fletchers, who made the shafts and attached the heads and fletching. During sieges where fighting could go on for months, bolt production was continuous. There are accounts of besieging armies setting up workshops to manufacture bolts on site, using local materials. Trees would be cut down for shafts, captured metal would be forged into heads, feathers from poultry would be used for fletching. The industrial scale of ammunition consumption in medieval warfare is often underestimated, but it was significant. Maintenance of crossbows was also crucial. The bowstrings, typically made from hemp, flax, or sinew, would wear out or break. A broken bowstring at the wrong moment could mean death, so crossbowmen carried spare strings. The bow itself, especially composite bows, was vulnerable to moisture. In the wet European climate, this was manageable, but in the more arid Middle East, it was actually less of a problem. However, extreme heat could affect the glue holding composite bows together. Crossbows needed to be stored carefully, kept clean of sand and grit that could jam the mechanism. The trigger mechanism, with its moving parts, needed periodic cleaning and sometimes repair. Professional crossbowmen learned to maintain their weapons, and armies employed specialized craftsmen to repair damaged crossbows. The transfer of crossbow technology between cultures was ongoing throughout the Crusader period. Europeans learned from Muslims about composite bow construction, which improved their crossbow bows. Muslims captured European crossbows and studied their trigger mechanisms and spanning devices, and incorporating some features into their own designs. There was also direct trade. Despite being at war, there were periods of truce and commercial contact. Weapons and weapon makers moved between the sides. European craftsmen sometimes ended up working for Muslim rulers, and vice versa. This cross-pollination of technology was one of the unintended consequences of the Crusades, advancing military technology on all sides. By the late 13th century, as the Crusader kingdoms were collapsing, the crossbow had become utterly standardized in European warfare. Every army had crossbowmen, every castle was designed with them in mind. They'd proven their worth so thoroughly that they were now considered essential. The Mamluks, who finally conquered the last Crusader strongholds in the 1290s, faced Crusader defenders equipped with the most advanced crossbows yet made. The Siege of Acre in 1291, the final fall of the city that had been so important throughout the Crusades, saw intensive crossbow duels. Mamluk forces had their own crossbowmen by this point, and the exchanges of fire were mutual. But the Mamluks ultimately won through overwhelming numbers and siege artillery, not through defeating the crossbow. The legacy of the Crusader crossbow extended far beyond the Crusades themselves. The tactical lessons learned, the technological innovations developed, the manufacturing techniques refined, all of these spread throughout Europe. The crossbow remained a primary military weapon through the 14th and into the 15th century. It was only gradually replaced by more powerful steel bows and eventually by early firearms. But even then, crossbows remained in use for specialized purposes well into the 16th century. Their influence on warfare was permanent. They'd proven that common soldiers with mechanical weapons could defeat aristocratic heavy cavalry. They'd shown that firepower and penetration could overcome armor and training. They demonstrated the importance of industrial production and logistics in warfare. All lessons that would be reinforced and expanded as warfare evolved toward the gunpowder age. The crossbow in the Crusades represented a pivotal moment in military history. It was a weapon that bridged the ancient and medieval worlds, drawing on technologies that were thousands of years old, but refining them to unprecedented levels. It changed who could participate in warfare, how battles were fought, what armor was needed, and how tactics evolved. For the Crusaders fighting far from home against numerically superior enemies, the crossbow was often the difference between survival and annihilation. It gave them the ranged firepower to compete with Muslim archery, the penetrating power to defeat armor, and the tactical flexibility to fight effectively in the diverse combat situations they encountered. From the sun-scorched plains of the Holy Land to the decks of ships on the Mediterranean, from the walls of besieged castles to the forests of Outremer, the crossbow was there, the mechanical heartbeat of Crusader military power, and when that distinctive snap of the trigger was followed by the punch of the bolt hitting home, it was a sound that shaped an age and changed warfare forever. The tactical sophistication of crossbow deployment reached its peak during the Fifth Crusade, particularly during the siege of Damietta in 1218 to 1221. This campaign demonstrated how far crossbow tactics had evolved from the relatively crude applications of the First Crusade over a century earlier. The Crusaders, led by various European nobles and supported by papal legates, faced a strategic challenge. Damietta was protected by the Nile itself, and the Muslims had constructed a massive chain tower in the middle of the river that prevented ships from advancing. Cardinal Pelagius, the papal legate effectively commanding the crusade, understood that taking this tower required something unprecedented. He commissioned the construction of what chroniclers called the Cog of War, a massive floating siege tower built on two ships lashed together. This structure rose multiple stories above the waterline and was essentially a mobile castle. But what made it truly formidable was its complement of crossbowmen. Over 200 crossbowmen were stationed on various levels of this floating tower, creating overlapping fields of fire. When the Crusaders finally moved this contraption into position against the chain tower in August 1219, the crossbow fire was so intense that Muslim defenders couldn't man their positions. The tower fell, not through assault, but through suppression. The defenders simply couldn't survive long enough on the walls to fight back effectively. the siege of Damietta itself became a masterclass in crossbow employment for both offence and defence. The Crusaders built siege lines completely surrounding the city, studded with wooden towers and fortifications. Every one of these positions was manned by crossbowmen. The Muslims inside Damietta had their own crossbowmen, and the exchanges of fire were continuous for over a year. Supply became critical. The Crusaders established workshops that produced hundreds of crossbow bolts daily. Chronicler Oliver of Paderborn, who was present during the siege, described seeing wagons loaded with nothing but bolts arriving at the siege lines. He estimated that tens of thousands of bolts were shot during the siege, possibly hundreds of thousands. The ground between the siege lines and the city walls became carpeted with spent bolts, so many that they were collected and reused when metal became scarce. This industrial scale of ammunition consumption was something new in warfare, a preview of the material-intensive conflicts that would define later centuries. The psychological warfare aspect of crossbows became increasingly sophisticated. Crusader commanders learned that the sound of massed crossbow volleys had an effect beyond the physical casualties inflicted. The sharp crack of multiple triggers releasing simultaneously, followed by the rushing sound of bolts in flight, created a distinctive audio signature that soldiers learned to fear. Muslim chroniclers noted that the sound of Frankish crossbow volleys could cause wavering in even veteran troops. The knowledge that the next volley might contain the bolt with your name on it, that there was nothing you could do to avoid it if it was aimed at you, that armour might not save you. This created psychological stress that accumulated over campaigns. Soldiers who'd survived multiple crossbow wounds often developed what we might today recognise as post-traumatic stress symptoms. They'd flinch at sudden sounds, have nightmares about bolts piercing their bodies, become reluctant to advance across open ground. This psychological dimension of crossbow warfare is rarely discussed in medieval chronicles, which focused on deeds of valour, but the evidence suggests it was significant. The development of specialised crossbow units within Crusader armies represented a major organisational innovation. Early Crusader armies had simply included crossbowmen as part of general infantry levies, but by the early 13th century, dedicated crossbow companies were being formed. These were professional soldiers who trained together, developed unit cohesion, and specialised in crossbow tactics. The Knights Hospitaller and Knights Templar, the great military orders, both maintained corps of crossbowmen as part of their military establishments. These weren't knights themselves, but sergeants and hired professionals who served alongside the knightly brothers. The Templars in particular became known for their crossbowmen. Templar fortresses like Chateau Pellerin and Safad were designed with extensive provisions for crossbow defence. The arrow slits were carefully positioned to provide overlapping fields of fire, creating kill zones where any attacker would face fire from multiple directions. The Templars trained their crossbowmen in standardised techniques and maintained quality control over equipment. A Templar crossbowman in one castle would be using essentially identical equipment and tactics as one in another castle hundreds of miles away. This standardisation improved effectiveness and allowed for easier replacement and reinforcement. The economics of maintaining crossbow forces was substantial, but manageable for well-organised military orders and wealthy nobles. A quality war crossbow in the mid-13th century cost roughly what a skilled craftsman would earn in 2 to 3 months. This was expensive, but not prohibitively so, especially compared to the cost of equipping a knight. A full set of knightly equipment, armour, weapons, warhorse could cost as much as a small estate. A crossbowman could be equipped for perhaps 1/10 that amount. The ongoing costs were mainly ammunition and maintenance. Bolts were relatively cheap to produce in bulk, and crossbows, while requiring occasional repair, were durable tools that could last for years with proper care. For Crusader states constantly struggling with limited resources, the cost-effectiveness of crossbowmen compared to heavy cavalry made them attractive. You could maintain 10 professional crossbowmen for the cost of one fully equipped knight, and in many tactical situations those 10 crossbowmen would be more useful. The training regimens developed for crossbowmen became increasingly sophisticated. Early training focused simply on learning to span the crossbow and shoot straight. But professional crossbowmen, particularly those serving in military orders or as paid mercenaries, received much more extensive instruction. They learned to estimate range, critical for effective shooting since crossbow bolts flew on flat trajectories and didn't have much margin for error in elevation. They practiced shooting at moving targets, essential for hitting cavalry. They drilled in formation shooting, coordinating with other crossbowmen to produce volleys. They learned to maintain their equipment, replace broken strings, adjust trigger mechanisms, and repair minor damage. They studied the vulnerabilities of different types of armor and learned where to aim to maximize the chance of a lethal hit. Against mail armor, aim for the chest or belly where vital organs were relatively unprotected. Against plate armor, aim for joints and gaps. Against cavalry, the horse was often the better target, especially the neck and chest. Advanced crossbowmen learned counter-battery fire, shooting at enemy archers and crossbowmen to suppress their fire. This required exceptional skill because you were shooting at small, partially protected targets who were also trying to kill you. The best crossbowman could hit a man-sized target through an arrow slit at 50 yards, a remarkable feat considering the small target area and the need to calculate trajectory precisely. These elite shooters were highly valued and often assigned to sniper roles during sieges. They'd take position in protected spots with good visibility and spend hours or even days waiting for high-value targets. Enemy commanders, engineers supervising siege works, soldiers manning important defensive positions, these were priority targets. A single well-placed bolt killing an enemy commander could change the course of a siege. There are several recorded instances of important Muslim commanders being killed by crossbow bolts during sieges, deaths that had significant strategic consequences. The crossbow's role in ambush warfare deserves particular attention. The Crusader kingdoms were crisscrossed with roads that passed through terrain ideal for ambushes, rocky hills, dense vegetation, narrow defiles. Crossbows were perfect ambush weapons. Unlike bows, which required space to draw and shoot, crossbows could be preloaded and held ready for extended periods. An ambush party could lie in wait with crossbows spanned and ready, then deliver a devastating first volley at point-blank range with no warning. The first indication of an ambush would be the sound of triggers releasing and men falling from their horses with bolts through their bodies. By the time surviving enemies reacted, the ambushers would be reloading or might have already faded away into rough terrain where cavalry couldn't follow. Muslim caravans and military columns learned to be extremely cautious when traversing areas where Crusader ambushes were possible. They'd send scouts ahead, maintain tight formations, and move quickly through dangerous areas. But even with these precautions, crossbow ambushes remained a constant threat that inflicted steady losses and tied down Muslim forces in guard duties. The technological arms race between crossbow and armour reached fascinating extremes by the mid-13th century. Armourers were producing specialised reinforced breastplates with thickened sections specifically to resist crossbow bolts. Some Italian armours from this period show a central ridge or reinforcement running down the centre of the breastplate, where a bolt fired from straight ahead would most likely hit. This extra thickness, sometimes up to a quarter-inch of hardened steel, could stop or deflect bolts that would penetrate standard plate. In response, crossbow makers increased draw weights even further and developed specialised armour-piercing bolt heads. These were essentially hardened steel spikes, sometimes case-hardened to create an extremely hard point, while leaving the body of the spike somewhat softer to prevent shattering. The very tip might be sharp, or it might be a blunt pyramidal shape designed to concentrate force on a tiny area and punch through by sheer impact. Tests with period-accurate reproductions show these could penetrate surprisingly thick armour at close range. The physics were simple. All the kinetic energy of the heavy bolt, travelling at perhaps 150 to 200 feet per second, concentrated on a point smaller than a pencil tip. Even thick steel couldn't always withstand that. Muslim metallurgists and armourers were conducting their own research. Mamluk armour from the late 13th century shows sophisticated attempts to defeat crossbow penetration. Some used multiple layers of mail over quilted armour over leather, the idea being that each layer would slow the bolt until it couldn't penetrate fully. This worked to an extent. A bolt that would punch clean through mail alone might get stopped in the underlying layers, resulting in a wound rather than instant death. Other armours used small plates sewn inside cloth garments, creating a kind of articulated protection that was flexible but resistant to penetration. The plates would overlap, and a bolt hitting the overlap might be deflected. These innovations spread throughout the Muslim world as knowledge from encounters with Crusader crossbows was systematised and shared. By the time of the Mamluk conquest of the Crusader states, Muslim armour had evolved significantly from the early Crusader period, specifically in response to crossbow threat. The siege of Antioch during the First Crusade in 1097 to 1098 provides an interesting early contrast to later sophistication. Contemporary accounts mention crossbows, but their use seems to have been relatively unsystematic. Crossbowmen shot opportunistically rather than in coordinated volleys. There wasn't yet the understanding of how to concentrate crossbow fire for maximum effect. The Crusaders won that siege through endurance, luck, and eventually treachery when a defender opened a gate, not through superior missile tactics. Compare this to the Siege of Acre a century later, where crossbow tactics had evolved dramatically. Coordinated volleys, rotational shooting, concentrated fire on key points, suppression of enemy positions, all of this was standard practice. The evolution in just a century was remarkable and spoke to how rapidly military technology and tactics were advancing during the Crusader period. The nightmare scenario for any medieval army was being caught in the open by a well-prepared enemy with superior missile weapons. This happened to Crusader armies several times with catastrophic results, most famously at the Battle of Hattin in 1187. But it also happened in reverse. The Battle of Jaffa in 1192 provides an example of crossbows saving a Crusader force from almost certain destruction. Richard the Lionheart's small army, perhaps 2,000 men including only a few hundred crossbowmen, was camped near Jaffa when Saladin attacked at dawn with overwhelming forces. The Crusaders were caught partially unprepared, not fully armoured, not in formation. In most circumstances this would have been a massacre, but Richard immediately ordered his crossbowmen forward to buy time. They formed a thin line and began shooting at the advancing Muslim cavalry. The rate of fire wasn't high, they were using hand-spanned crossbows primarily, but every shot was accurate and deadly. Horses and men went down. The Muslim advance hesitated. That hesitation gave Richard time to organise a proper defensive position. His knights formed up behind a shield wall, and the crossbowmen continued their work. When Muslim cavalry finally charged, they hit a prepared position, and the attack failed. The crossbowmen had provided the critical minutes needed to turn chaos into organised resistance. The role of crossbows in naval engagements expanded significantly during the later Crusades. The Italian maritime republics, Venice, Genoa, and Pisa, which provided much of the naval transport and support for Crusader armies, armed their war galleys with crossbowmen as standard practice. A typical war galley might carry 20 to 40 crossbowmen in addition to its rowing crew and marines. These crossbowmen were positioned on raised platforms at bow and stern and sometimes along the sides. In naval combat, which often involved galleys trying to ram and board each other, the crossbowmen provided crucial fire support. They'd shoot at enemy rowers trying to disable the enemy galley by killing the men who powered it. They'd target enemy crossbowmen in counter-battery duels, and critically they'd provide covering fire for boarding actions. When galleys closed to boarding range and marines prepared to leap across, crossbowmen would pour fire onto the enemy deck, trying to suppress defenders and clear space for the boarders. The confined spaces of ship decks made crossbows particularly effective. There was nowhere to take cover, and a bolt could easily penetrate the wooden sides of galleys at close range. The Battle of the Masts in 1123, a naval engagement off the coast of Palestine, demonstrated crossbow effectiveness at sea. A Venetian fleet carrying Crusader reinforcements encountered a much larger Egyptian fleet. The Venetians were outnumbered in ships, but had superior crossbow firepower. As the fleets closed, Venetian crossbowmen opened up from elevated positions on their ships. The Egyptian vessels, packed with soldiers, presented target-rich environments. Bolts rained down onto enemy decks with devastating effect. By the time the ships came together for boarding, the Egyptian vessels were already in chaos, crews depleted, command structures disrupted. The Venetians won decisively, destroying or capturing most of the Egyptian fleet. Crossbows had been a major factor in that victory. The psychological impact of crossbow fire on sailors and soldiers confined to ships was immense. On land, you could at least try to take cover or retreat. On a ship, you were trapped. If crossbow fire started hitting your vessel, all you could do was endure it until ships closed to fighting range. Many men must have experienced the terror of watching bolts thud into the deck around them, seeing comrades fall with bolts through their bodies, and being completely unable to respond or escape. The evolution of bolt design during the Crusader period reflected the increasing sophistication of crossbow warfare. Early bolts were relatively simple, iron heads on wooden shafts with leather or feather fletching. But as armourers improved armour, bolt makers had to improve their products. By the 13th century, specialised bolt heads were common. Type 1, the standard bodkin, a narrow pointed head designed for male penetration. These might be square in cross-section or diamond-shaped, typically 2 to 4 inches long, hardened at the tip. Type 2, armour-piercing bodkins, longer, thinner, sometimes called needles. These were specifically for penetrating plate armour and could be 6 inches long, thin as a modern nail, and extremely hard. They were fragile, prone to bending or breaking if they hit at an angle, but against a flat plate hit straight on they could penetrate remarkably well. Type 3, broadheads, wide cutting heads used against unarmoured targets and horses. These came in various shapes, some with barbs, some smooth, designed to cut blood vessels and cause rapid bleeding. Type 4, specialised heads. These included blunt heads for stunning rather than killing, useful for capturing prisoners. Forked heads designed to cut ropes or rigging during naval combat. Incendiary heads with cavities that could hold burning material for starting fires. Even poisoned heads, though these were rare and controversial. The fletching on crossbow bolts also evolved. Early bolts used feather fletching similar to arrows, but feathers were expensive and not always available in the quantities needed. Leather fletching became common, cut from thin leather into triangular shapes and glued to the shaft. This was cheaper and more durable than feathers, though perhaps slightly less efficient aerodynamically. Some bolts used wooden fins, thin strips of wood glued to the shaft. These were the cheapest option and were often used for practice bolts or in situations where huge quantities were needed and cost was a concern. The number of fletchers varied, but 4 was most common, arranged in a cross pattern. This provided good stability without adding excessive weight or drag. The fletchers were typically 3 to 5 inches long on a 14-inch bolt, and they were crucial for accuracy. A bolt without proper fletching would tumble in flight and be wildly inaccurate beyond a few dozen yards. The shaft material and construction was another area of innovation. Most shafts were made from hardwoods like ash, oak, or birch. The wood had to be straight-grained and free of knots or defects that could cause the shaft to break under the stress of acceleration. Some high-quality bolts used heat-treated or compressed wood, processes that made the wood denser and stronger. The very best bolts might have metal reinforcement, thin strips of iron or steel inlaid into the shaft near the head to prevent splitting on impact. The notch at the back of the bolt that engaged with the bowstring, was a critical weak point. If the nock split or broke, the bolt couldn't be shot. Some makers reinforced the nock with horn or hardwood inserts. Others used metal nocks, though these were expensive. The entire bolt had to be balanced carefully. Too much weight forward and it would nosedive in flight. Too much weight back and it would be unstable. Good bolt makers achieved balance through careful selection of materials and by adjusting the size and weight of the head and fletching. The industrial production of bolts in large quantities required organisation and specialisation. A major siege might consume thousands of bolts per day, and maintaining that supply required dedicated production facilities. We have records from various Crusader sieges of workshops being established specifically to produce ammunition. These would have division of labour. Some workers would prepare shafts, cutting them to length, shaping them and smoothing them. Others would forge heads, working at forges to produce the iron and steel points. Fletchers would attach the fletching. Final assembly would bring all the components together. Quality control was important. A defective bolt could jam in the crossbow's channel or fly erratically, potentially endangering the shooter or nearby friendlies. Inspectors would check bolts for straightness, proper balance, and secure attachment of components. Rejected bolts might be set aside for practice or simply discarded. The best bolts, those intended for combat, had to meet strict standards. The logistics of supplying crossbow-equipped armies extended beyond just the bolts. Spare crossbows were needed because weapons broke or were damaged in combat. Spare strings were essential. Strings broke frequently, especially in combat conditions. Spanning devices, the levers and windlasses, also needed spares. Tools for maintenance and repair, files, wrenches, spare trigger components, glue for repairs, oil for lubrication, all of this had to be transported and stored. A Crusader army on campaign was followed by extensive baggage trains carrying supplies, and a significant portion of that baggage was ammunition and equipment for the crossbowmen. The organisation required to maintain this supply chain was sophisticated for the medieval period. There had to be inventory management to know what was needed and where. Transportation had to be arranged, often difficult in the poor road conditions of the Middle East. Storage had to protect supplies from weather and theft. All of this required clerks, overseers, guards, and labourers. The military logistics of the Crusader period were far more complex than popular imagination often assumes. The interaction between crossbowmen and other military arms was crucial to tactical success. Crossbowmen weren't effective in isolation. They needed protection from cavalry charges, which meant they needed to work with spearmen or knights. They needed to be positioned where they had good fields of fire and some protection, which required understanding of terrain and fortification. Coordinating crossbow fire with cavalry charges was an art. The ideal was to use crossbow fire to disrupt and disorder the enemy, then launch a cavalry charge into the disrupted formation. This required timing and communication. Crusader commanders used various signals to coordinate actions, horns, flags, even specific painted shields raised to indicate commands. A horn blast might signal crossbowmen to advance and begin shooting. A different signal would tell them to cease fire and take cover while cavalry charged through their position. These coordinated attacks, when executed well, were devastating. The enemy would be under crossbow fire, taking casualties and losing cohesion. Then, before they could recover, heavy cavalry would smash into them. Caught between missile fire and shock combat, enemy formations would often break and run. The moral courage required to stand in formation and maintain crossbow fire while enemy cavalry charged at you cannot be overstated. Cavalry charges were terrifying. Masses of armoured men on huge horses thundering toward you at 30 miles per hour. Every instinct screamed to run, but running meant death. The charge would overtake and ride down fleeing infantry. The only chance of survival was to stand, keep shooting, trust that your bolts would bring down enough horses and men to break the charge before it hit you. This required not just individual courage, but collective discipline. If a few men broke and ran, it could cascade into mass panic. Crusader crossbowmen developed a reputation for steadiness under fire that was well earned. Time and again they held positions against overwhelming charges, maintaining fire discipline until the last possible moment. This steadiness was a product of training, unit cohesion, confidence in their weapons, and leadership. Good commanders positioned themselves with the crossbowmen during critical moments, sharing the danger and setting an example. The development of combined arms tactics involving crossbows reached its sophisticated peak in the campaigns of Frederick II during the Sixth Crusade in 1228 to 1229. Frederick was an unusual crusader, more interested in negotiation than fighting, but he understood military organisation and tactics. His army included large contingents of professional crossbowmen, many from Italy, organised into companies with clear command structures. Frederick used these crossbowmen as a flexible tactical reserve. When Muslim forces probed his positions, crossbowmen would move to that point and reinforce the defence. When Frederick wanted to seize a position, crossbowmen would advance, take cover, and provide suppressive fire while other troops moved up. This mobile, responsive use of missile troops was more sophisticated than the static deployment common in earlier Crusades. It required good training, effective command structures, and probably pre-arranged signals and procedures. Frederick's success in negotiating favourable terms from the Sultan of Egypt was partly based on the Sultan's respect for Frederick's military capabilities. Those capabilities were built significantly on his professional crossbow companies. The crossbow's effectiveness in urban combat became increasingly relevant as Crusader warfare evolved. The Crusader kingdoms were dotted with fortified towns and cities, and fighting in these urban environments had unique characteristics. Narrow streets channelized movement and created perfect kill zones for crossbowmen positioned in buildings or behind barricades. The stone buildings provided excellent protection, and loopholes could be knocked through walls to create firing positions. Attacking forces had to advance through streets where they could be shot at, from windows, rooftops, and fortified positions, often from multiple directions simultaneously. Defending a town with crossbowmen meant every building could be a strong point, every street corner a death trap. Muslim forces attempting to take Crusader towns learned to be extremely cautious of urban areas defended by crossbowmen. The Battle of Arsuf in 1191 demonstrated the effectiveness of crossbows in urban combat when Richard the Lionheart's forces defended Jaffa. Every street had crossbowmen in prepared positions, and Muslim attackers were slaughtered as they tried to advance through the narrow urban terrain.